Hello and welcome to another Common Core Geometry video by eMathInstruction. My name is Kirk Weiler and today we'll be doing Unit number 9, Lesson number 10, on placing a circle in standard form. Alright, so in the last lesson, which is key to this lesson, we learned about the equations of circles and how to identify both the center of the circle and the radius of the circle from its equation. You have to have that background before you do this lesson or it's not going to help at all. And in fact, we're going to launch right in the first exercise by reviewing those skills. So let's take a look. All right, the general equation of a circle, right? If we know the coordinates of the center of the circle, x sub c, y sub c, and we know the radius of the circle, r, then we can write the equation of the circle, or we can identify from the equation of the circle the center and the radius by x minus x sub c squared plus y minus y sub c squared equals r squared. Remember, the equation of a circle essentially comes from either the distance formula or the Pythagorean theorem, either way you want to think about it. So in exercise number 1, it asks us to determine the center and the radius of each of the following circles. So what I'd like you to do is see how prepared you are for this lesson by pausing the video and tell me what the center and the radius of each one of these circles is. All right, let's go through them. X squared plus y squared equals 100. This is an example of a circle which is centered at the origin. Effectively, x sub c is 0, y sub c is 0. So the center is at 0, 0, and the radius is equal to 10. Remember, this number here is not the radius, it's the square of the radius, not the square root, the square. In fact, if you ever want to find the radius, you take the square root of that number. So then when we move over to this equation, right, our center is at 5, 2, and our radius is at 6. Not at, but is 6. All right? And finally, when I have x plus 2 squared plus y minus 11 squared equals 1, I can say that the center is at negative 2, 11, and the radius is the square root of 1, which is also 1. All right? That's it. You've got to have that down before we move on to what we're going to do today. All right, let's do it. Now, basically, let me give you the foreshadowing of what's going to happen today. When equations of circles are in the form that we just saw them, it's very, very easy to identify the center and the radius. But oftentimes circles aren't in that form, and we have to manipulate them algebraically to put them in that form. In order to do that, we use the process known as completing the square. You learned about that process and used it extensively in Algebra 1, all right? The good news here is that when we complete the square in today's lesson, it's going to always be fairly easy in terms of completing the square. Let's review how to do that, though, in this exercise to solve a quadratic equation. All right, now that's not what we're going to be doing today. We're not going to be solving quadratic equations in general, but it's a good way to review the algorithm of completing the square. So let's take a look. Exercise number 2. Solve each quadratic below by using the method of completing the square. All right, so let's take a look at this. All right, completing the square basically works as follows. You take the first two terms and you group them together. Whoops, I don't know what happened there. You group them together like that. Okay, and we can do that. That's called the associative property of addition. All right, we're just grouping those two together. Some teachers will automatically say, take that negative 39 and throw it on the other side. That's okay as well. In that case, I don't really need the parentheses on this side. I can just put that 39 over here. Now, how do I complete the square on this? Well, number 1, in order to complete the square, the coefficient on the x squared or y squared or whatever squared term has to be equal to 1. It can't be 2, it can't be 5, it can't be 22. It's got to be equal to 1, which in this case it is. Then what you do is you take the coefficient of the linear term, the number that's multiplying x to the first or y to the first or whatever, and you divide it by 2. So you take 10, you divide by 2, and you obviously get 5. All right? When you do that, you then take that and you square it and you add it on. So I do x squared plus 10x plus 25. But an equation is a balancing act. what you do to one side of the equation, you should do to the other side. So if I add 25 to the left side, I should add 25 to the right side. Okay? Now, by taking half of the b term, okay, and squaring it and adding it on, we ensure ourselves that that trinomial, three-term polynomial, is a perfect square, so that it can be factored as a binomial times itself. In fact, this particular one factors as x plus 5 times x plus 5. Over on this side, right, we can just add these two together and we get 64. All right. Now the point is, over on this side, x squared plus 10x plus 25 factors into x plus 5, so it factors into x plus 5 squared. In Algebra 1 then, you took it from here and you said, all right, I can now take the square root of both sides, and I'll get x plus 5 is equal to plus or minus 8. All right, the rest of this, we can just say x plus 5 is equal to negative 8. X plus 5 is equal to positive 8. In this case, x would be negative 13 and 3. All right. Now, honestly, all of that is not really all that relevant to what we're doing today. But it's something you did last year that used completing the square. So hopefully it kind of wakes up some dormant memory cells that you've got there from last year. And in fact, I'd like you to try to do the same in letter B. And then we'll review that. All right, let's go through it. Again, mostly what I need you to know is that whole idea of taking half of the b term, half of the linear coefficient, squaring it and adding it on, and then factoring to get this binomial squared. So let's take a look at that. In this case, I'm going to immediately swing that negative 7 to the other side, write it as positive 7. Okay. I'm going to take half of negative 6, which is negative 3, and when I square it and add it on, it's a positive 9. And I'm going to add that 9 to both sides, right? So again, half of negative 6 is negative 3, squared is 9, add the 9 to both sides, very important. This now ensures that x squared minus 6x plus 9 is a perfect square trinomial. In fact, it is. It factors as x minus 3 times x minus 3. All of this is 16. This, of course, then is x minus 3 squared. That's really the whole point. The whole point is that x squared minus 6x plus 9 can be written as a binomial squared. Now, to finish it all off, I'll take the square root of both sides, and I'll get x minus 3 is equal to negative 4, x minus 3 is equal to positive 4, x is equal to negative 1, and x is equal to 7. All right, so easy enough. Again, the primary thing that you need to be able to do in today's lesson is remember how to do this, and then how to factor it into x minus 3 squared. All right? Step back, take a look, and then we'll move on. All right, let's do it. So how does this connect to what we've been doing? Well, let's take a look at exercise number 3. A circle has an equation shown below not in standard form. X squared minus 4x plus y squared minus 8y is equal to 5. Use the process of completing the square twice. Write this equation in standard form. All right, so what I want is I want to be able to do, or I want to have what I had in exercise 1. I want to have it all. But what I really want right now is to have this thing written as x minus x sub c squared plus y minus y sub c squared equals r squared. So let's see how we do that. All right, I'm going to write this equation down again. X squared minus 4x plus y squared minus 8y is equal to 5. And I'm really kind of thinking about it grouped like this, all right, where I've got the x terms grouped together, the y terms grouped together. I'm going to complete the square for this, complete the square for that, and then we'll have the equation written in standard form. All right, so what do I need to do to complete the square here? Well, I need to take half of that negative 4, which is negative 2, squared and added on, I get 4. Now, right away, I should also add that 4 to the other side of the equation. Plus 4 here, plus 4 there. Now let's do it for the y. So in that case, I'm going to take half of the negative 8, and that's negative 4. I square it, and I get 16. I'm going to add it on there, and I'm going to add it on here. Okay? Now, since I've done the process correctly, this trinomial should be a perfect square, and this trinomial should be a perfect square, and they are. This particular one is x minus 2 squared, and this particular one is y minus 4 squared. And of course, over here, 5 plus 4 plus 16 gives me 25. And now we've got the equation written in standard form. X minus 2 squared plus y minus 4 squared equals 25. As an aside, if you're struggling because you have forgotten some things from last year, and you don't really remember how to get this x minus 2 and this y minus 4, one thing to note, when I do half of the negative 4, I get minus 2. And look at that, x minus 2. When I do half of the negative 8, I get negative 4, y minus 4. That will always be the case. The x plus or minus here, the y plus or minus here, will always be that half of the b, right? Whatever it is, it will be half of that sitting there. And that's kind of nice, all right? Because then that allows you to factor these quicker. Now, let me go back to blue. Letter B asks us, well, what are the center and the radius of this circle? That should now be easy. Why don't you go ahead and pause the video and write them down? What are the center and the radius of this circle? Well, they're 2, 4, that's the center, 2, 4, and the radius is the square root of 25, or 5. So the center is at 2, 4, and the radius is 5. Finally, letter C asks us to graph the circle on the grid to the right, okay? Anytime you're asked to graph a circle, make sure that you use a compass, okay? You want to use a compass, you want to get the best circle you can. Now this is what I typically do. I plot the center, 2, 4. Let me do that, all right? And I also tend to plot what I would call 4 sort of important points. I literally take the center and I'll go 5 units up, 5 units down, 5 units to the left, 5 units to the right. Let me just move my compass out of the way. All right, here's 5 units to the right, 5 units to the left, 5 units above, and 5 units below. You don't absolutely have to have those 4 graphed, but it's kind of nice because then when you bring your compass up, all right, maybe bring my paper up a little bit, stretch this out, and you really have like a good sense for the graph of your circle, right? And there it is. Maybe not the darkest line on earth, but it gets the job done, right? So let me step back so that you can really take a look at this work. This is the most important thing that we did in this problem because it's the first time that we took a circle not in standard form, and through completing the square twice, 1, 2, we were able to get it into that nice form where we can identify the center and identify the radius. So take a second. All right, let's move on. So what do we have next? There we go. Took a little while there. Hold on. Yep. All right, just a little practice here, all right? We want to get good at taking equations of circles that aren't in their center radius form and putting them in that form. So let's go through letter A in this problem together and then have you work on letter B by yourself. One of the things that's nice again about these problems is that they're all done in the same way. You should get good at them because there's almost always one of these on a standardized exam that's tied to the Common Core geometry standards. It is literally in the standards themselves. Students will be able to write an equation in the standard form by completing the square in order to identify the center and the radius of the circle. Whew. Anyway, let's do that. Exercise number 4. For each of the following equations of circles, place them in standard form and then identify their center and radius. All right, here we go, letter A. I'm going to group these 2 terms together and these 2 terms together. I'm going to look at the first one, x squared plus 8x, right? I'm going to take half of that positive 8. I'm going to get positive 4. I'm going to square it and add it on, and that's going to give me 16. Immediately, I'm going to add that 16 to the right-hand side as well. Then I'm going to take my y squared minus 4y, right? I'm going to take half of negative 4, get negative 2, square it, add it on, and I'm going to get positive 4. Add that positive 4 to both sides, right? Half of 8, 4, square it, 16. Half of negative 4, negative 2, square it, 4. Add 16, add 4. This now should be a perfect square trinomial. It is. It's x plus 4, quantity squared. This should also be a perfect square trinomial, y minus 2, quantity squared. When I add all of these three together, I get positive 4. We now have the circle in its center and radius form. Should be easy now. The center of my circle is at negative 4, comma positive 2, and the radius is equal to 2. All right? That's it. All right, why don't you pause the video now and take a shot at letter B. All right, let's go through it. I've got my handy dandy little calculator here just in case we needed to do some of the calculations. I'm going to move it over here though just for the moment. Let's take a look at letter B. All right, we've got x squared minus 18x as one grouping, y squared minus 10y as another grouping. Let's do it. That negative 18x, we take half of negative 18, and that's 9. We square it, and we get 81. Right? We'll put that 81 on the other side in just a second. In the other case, we've got our y squared. We've got stray pen all over the place. Let's go back. We've got y squared minus 10y. We take half of negative 10, and that's negative 5. We square it, add it on, and that's 25. On this side, we're going to get negative 6 plus 81 plus 25. And we're going to run out of room a little bit. Oh, really? Really? No, I was kind of hoping that would all just stay. That's all right. It's good enough. We just never got that plus 25 there. There it is. Okay. So now we should factor, and we're going to get x minus 9, quantity squared here. We're going to get y minus 5 squared there. And we're going to get 81 plus 25, and then minus 6. And we're going to make that equal to 100. We've now got it in our center radius form. X minus 9 squared plus y minus 5 squared equals 100. Simple to get the center and the radius at this point. The center is at 9, comma 5. And the radius is equal to 10. All right, so hopefully you were able to get that one. Take a look at the work, and then we'll move on. All right, let's do it. Now, we're still in exercise number 4, because there's not very much that can kind of push you in these problems. You know, you have to know the algorithm for completing the square. You have to know sort of the proper steps to do that, but ultimately there's still the same problem again and again. One wrinkle that we've seen though, that they will sometimes do, is they'll have that the coefficient on the x squared and the y squared won't be equal to 1. The process of completing the square cannot be done if that coefficient isn't 1. I mean, it can be done, but it's a whole different algorithm and it's a pain. So when you see a coefficient on x squared or y squared that isn't 1, you've got to get rid of it. But the good news is, if there is a coefficient on x squared, like 2, it'll be the same as the coefficient on the y squared, also 2. And to get rid of it, you'll simply divide both sides of the equation by whatever that coefficient is to get rid of it. Keep in mind, though, that you can't pick and choose. Division, like multiplication, distributes. So if I divide this side by 2, I have to divide that side by 2, and I have to divide every single term on this side by 2. Now that's easy enough. 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. 2y squared divided by 2 is y squared. Minus 4y divided by 2 is negative 2y. And 14 divided by 2 is 7. Right? That's all we have to do, and we're going to have to do the same thing over here with 5. Simple enough. All right, let me now go through and do the completing the square on this one again. All right, let's take a look. So we've got x squared plus 2x. When I divide 2 by 2, I get 1. Square it, and I still have 1. right? Same thing's going to happen here. Y squared minus 2y, divide negative 2 by 2. I get negative 1 squared, and I get 1. And then over on this side, I have 7 plus 1 plus 1. Our x squared plus 2x plus 1 will factor as x plus 1 squared. Here, this will factor as y minus 1 squared. And of course, that all becomes 9, right? Perfect square trinomial, factor, factor. Now the center and radius are easy. The center is at negative 1, 1, and the radius is equal to 3. All right. Why don't you go ahead and do the same process over here in letter D. All right. Well, again, we have to start by getting rid of those two 5s. The 5x squared and the 5y squared, we can't have those. So we divide both sides of the equation by 5. Let me just draw a line here. 5x squared divided by 5 will just be x squared. 70 divided by 5, 14. So minus 14x plus y squared minus 4y. 260 divided by 5 is 52 equals 0. All right, I don't think I need that right now. All right, now I have to do the process again here. There's one added wrinkle, which is the fact that this positive 52 is hanging out here. All right, just like before, it's a good idea to kind of shove that 52 over to the other side, where it of course will become negative, because ultimately, to move it to the other side, what we're really doing is subtracting a 52 from both sides. 0 minus 52 is negative 52. I'm going to do this kind of all at once. First, let me start by completing the square on this. X squared minus 14x, take half of negative 14, get negative 7, square it, and we get 49. Here, we're going to have y squared, take half of negative 4, that's negative 2, square it, and that's 4. Over on this side, though, we're going to have negative 52, right, plus 49, plus 4. Whoops, plus 4. There we go. All right. This will now factor into x minus 7 squared. This will factor as y minus 2 squared. And all of that adds together to just be positive 1, right? Because we have negative 52 here. We really have positive 53 here. Those combine to be just positive 1. But again, center radius now easy. My center is at 7, 2, and my radius is equal to 1. That's it. It's the whole story. All right, step back, take a look, write down what you need to, and then we'll move on to another problem. All right, let's do it. Last problem. Graphically solve the system of equations shown below, right? Systems of equations. 2 or more equations, and when we solve them graphically, what we're trying to do is find their intersection point. Now, what we've got here is we've got the equation of a line, and we've reviewed how to graph equations of lines, obviously in this course. And then we've got the equation of a circle written in non-standard form. Now, the equation of the line shouldn't be any big deal to graph, but the circle is more challenging because we need to know its center and its radius in order to graph it. So, let's kind of jump into that. All right, let's not worry about this just for a moment. Why don't you pause the video now, complete the square on this circle, okay, or complete the square twice on this circle to place it in standard form, and then graph the circle. If you can, graph the line as well, and find out where they intersect. Then we'll go through the entire problem at once. All right, let's go through it. So I'm going to deal with the circle first. We'll come back to the line in just a little bit. That's pretty easy. So let's do the completing of the square. We've got x squared minus 12x. All right, when I take half of negative 12, I get negative 6, and I square it, add it on, get 36. Then we have y squared minus 8y, take half of negative 8, that's negative 4, square it, and we get 16. All right, on this side we have negative 27 plus 36 plus 16. All right, x squared minus 12x plus 36 factors into x minus 6 squared. Here we've got y minus 4 squared. When we rack all of that together, we get 25. All right? So it's easy, right? Now we've got a circle whose center is at 6, 4, and whose radius is equal to 5. Why don't we go ahead and graph that? All right? Let's take a look. We've got 6, 4. Beautiful. Right? Maybe I'll go out 5 in this direction, and 5 in this direction, 5 up, 1, 2, 3, 4, 5, and 5 down, 1, 2, 3, 4, 5. Okay, get the graph of my circle. Maybe try to get the width a little bit bigger this time. I think this will do it. All right, not great actually. I should have had that thing expanded a little bit further. Hopefully it'll be good enough. Let's talk about the equation of this line. Maybe we'll do that one in red. Okay. You could graph this line in many different ways. You could just create a bunch of coordinate points if you wanted to. You could identify the slope, the y-intercept. I think that's the way I'm going to go with it. The y-intercept of this line is -1. And the slope is 1, which, if it helps, 1/1, right? Which is going to kind of be like this. And then we're going to see the limits of the accuracy of the graphing of the circle. Now, as always, when you graph, you should make sure to write down the equations that you're graphing. So for instance, our line, y equals x minus 1, and our circle, let me go back down to blue. Don't get me wrong, I think it's pretty obvious which one's the circle and which one isn't. All right, but is x minus 6 squared plus y minus 4 squared equals 25. All right, and that should be labeled. All right. Now, this does, though, show you how bad it is when the graph of your circle is a bit off, right? Because the answers to my system should be these 2 points. They should be the point 2, 1 and the point 9, 8. All right. Unfortunately, because I didn't make my circle overly accurate, it kind of missed those intersection points here and here. And you can see I just didn't make the radius of my circle quite large enough. All right. So be careful about that. Cautionary tale. Overall, though, the problem is solid, right? We have to put the equation into its center radius form in order to simply graph it, right? And then we've got the equation of the line. Overall, again, we're looking for those intersection points, 2, 1 and 9, 8. All right, so take a little bit of time, write down anything you need to, and then we'll wrap up. All right, let's do it. So, today's lesson, we reviewed the center radius or standard form of a circle. More importantly, though, we saw the algebraic technique of completing the square and how it's used to take circles that aren't written in that standard form and then write them in that way. All right? The key is, and the big difference between completing the square this year and doing it last year in Algebra 1, is that this time we have to do it twice typically. Once to the x sort of quantities and once to the y quantities so that we can identify both the x coordinate of the center and the y coordinate of the center, and of course the radius. We also saw how to sort of put that together when solving a system of equations to find the intersection points of, at least in this case, a circle and a line, even though I didn't really do the circle as well as maybe I should have. All right, so cautionary tale. Make sure to really get your circle, your radius, and the center in the proper place. For now, though, I'd like to thank you for joining me for another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.